Okay, so I need to add a couple more things to the quantum model and electronic structure um, because I forgot to include it. Okay, so we'll go over it. They are the quantum numbers and how they relate to orbital energy diagrams, and two, noble gas form, which is related to electronic configuration. They're kind of independent of each other. Okay, quantum numbers we covered when we talked about quantum, and and noble gas form is going to relate to electronic configuration. So the first thing is quantum numbers and orbital energy diagram. In the quantum series of PowerPoints, I think it was the third one, I mentioned quantum numbers when Bohr came up with his model. And quantum numbers are ways of quantifying energy levels, subshells, orientations, orbits, and spins. The OED model all has these as well. Okay, so we can take the quantum number info and apply it to the OED and vice versa. So let's go back and look at what quantum numbers are. The first quantum number is called the principal quantum number, and it gives me the energy level, and it's labeled letter N, and it's numbered 1, 2, 3, 4, 5, 6, etc. Okay, so energy level 1 would have a quantum number of 1. The second quantum number is called L, and it represents basically the subshell. Okay, the numbering's a little different, but it still goes up by ones. If you have an S subshell, it has a 0. If it's a P subshell, it's given a value of 1. If it's a D subshell, it's given a value of 2, and so forth. Okay. Right, the third quantum number, M, represents the orientation of the subshell. So remember, S has one orientation, just one orbital. A P, okay, had 3 orbitals, and each orbital represents orientation. So for S subshell, that one orientation gives a value of 0. For P subshell, the values go -1, 0, +1. Okay, D subshell has 5 orbitals. 1, 2, 3. Okay, so the middle one will be 0, -1, -2, and the other way is +1 and +2. Okay, all right. And then the fourth quantum number is the spin. If it's up, it's +1/2, and down spin is -1/2. All right, here's an example. So here I have an electron. It's an up, it's in the P's, and it's in the third energy level. So let's write the quantum number. So energy level is 3. Subshell is P. Okay, this should be 1. All right, because S is 1, S is 0, P is 1, D is 2. M, it's in the middle orientation. So this is -1, this is 0, and this is +1. So 0. And the spin is up, so it's +1/2. Okay. All right. Now here's the thing that Pauli came up with that also relates to his exclusion principle. He said that no two electrons can have the same quantum numbers. All right. And so there were different ways you can interpret Pauli's exclusion principle. Like you can't have two electrons up in the same orbital. You can't have more than 2 electrons in an orbital. But this is one of the ways he actually expressed it. Okay, example number 2. Okay, I have this electron. So what is its quantum number? It's in the third energy level, so it's 3. Okay, it's in the D's, so S's are 0s, P's are 1, and D's are 2, so it's 2. All right, the M is at -1. And the spin is -1/2. Okay, so there you go with quantum numbers. Okay, now let's go to noble gas form. So noble gas form, it will be a shortened version of electronic configuration. You know, when we do electronic configuration, they can get kind of unwieldy. And here's an example is beryllium. So beryllium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and then 5p4. Okay, so right there. And we went over that in PowerPoint. So I'm actually going to divide it up in rows. So row 1 is 1s2. Okay, row 2 is 2s2, 2p6. Row 3 is 3s2, 3p6. Row 4 is 4s2, 3d10, 4p6. And the last row is 5s2, 4d10, 5p4. Okay, so if you look, these first 4 rows, okay, when they're all filled up, have the electronic configuration of krypton. So what we're going to do is we're going to replace all of this right here with krypton. All right. Okay, so we just write down Kr. And then what we do is we write down the electron configuration of the last row, which is 5s2, 4pd10, 5p4. Okay, and that's it. Okay, it gives us the information we need. It tells us it has 6 valence electrons. All right, and it has 5 energy levels. You can find that out by the highest number here. Okay, so the noble gas form is simply the last noble gas, right? Okay, and the electronic configuration of the last element. Now, one thing you don't do. All right, let me go over this. Let's say you want to come up with the noble gas form of sulfur. All right. Now, a lot of students, what they do is they would just go, oh, I'm going to just write P, because that's the last element before sulfur, and then write down 3P4. Okay. You don't do that. Okay. You use the previous noble gas. So if it's sulfur, previous noble gas would be neon. Okay. And then it would be 3s2, 3p4. Okay. Right, so that's it.